Hello and welcome to this section on how to name alcohol groups. So first off, the alcohol group in organic chemistry is generally given by the form of ROH. Now R stands for the rest of the molecule for all intents and purposes, any carbon containing group. So this is a carbon group connected to covalently bonded to oxygen, which is then covalently bonded to a hydrogen. So think of alcohols as alkyl derivatives of water. Water with its central oxygen and two surrounding hydrogens. This has a bent shape due to the lone pair of electrons on the central oxygen. And what an alcohol group does is it essentially replaces that one of the two hydrogens with a carbon containing R group. So it is then a carbon or organic containing derivative of water. You're simply replacing one of the two hydrogens off of water to make this special derivative. So how do we name alcohols? Well, first off, alcohols in terms of priority are now higher than the earlier functional groups that we've discussed. So higher than alkenes, higher than alkynes, higher than all the alkane and alkane derivatives that we discussed, alkyl groups, cycloalkyl groups. We'll get into aromatic groups soon enough. General rule goes like this. So what you want to do is similar to that of alkanes, except for now you're going to be adding that, again, addendum onto the very first rule, which is find the longest continuous carbon chain. Now we add the extra bit on it, which is containing the highest priority group. Okay, our highest priority group here in this molecule is the alcohol OH group. And what you want to do is find the longest continuous carbon chain, and you start off by giving the lowest possible carbon number to the carbon that has the alcohol group directly attached. Now, I can start off here at 1, 2, 3, 4. I have a 4 carbon long chain. The alcohol group is coming off of carbon number 1. 4 carbon long chain according to my alkanes is butane. Now for alcohols, we drop the E of the suffix and add OL. So here are suffix at the end of our parent name to let us know that this is not an alkane or an alkene, but rather an alcohol, is the use of OL. So this is butanol, much like what we saw earlier with parent chains with alkenes in which the double bond was located off of carbon number 1. We do not necessarily have to put a number 1 in front of the butanol because 1 is implied. We would only need to place a number on it if the location of that alcohol group was on any other carbon other than 1. Say, like, for example, carbon 2. So we can continue with the substituents off of here. I've got a chloro group coming off of carbon number 3. So 3-chlorobutanol. So that would be the appropriate name for this alcohol group. Let's take a look at another example here. Okay, so here's a few more examples on how to name alcohol functional groups. In the following example, I have a alcohol group located here. I want to make sure to give this highest priority alcohol group the longest continuous carbon chain, while at the same time giving the lowest possible carbon number for the carbon that the alcohol group is attached to. So if I number here, I go 1, 2, 3, 4, 5. I get a 3 for the alcohol going in this direction. For the other direction, I also get a 3 in the other direction. So both directions give me 3 for the carbon number. So if there is no preference in either direction with regards to the carbon number that the alcohol group is on, then you take a look at, okay, are there any substituents located on my chain? In this case, there is. This methyl group coming off needs to then have the lowest possible carbon number, preferably. And since it doesn't matter to us which direction we number for the alcohol carbon, we'll go ahead and number in this kind of counterclockwise direction. That will give us a lowest possible carbon number on our methyl substituent at carbon 2. So first off, 5 carbons. Pentane, we drop the E, add OL. And because this is located on something other than carbon 1, we definitely want to place a carbon location number in front of our parent chain. So carbon number 3, 3-pentanol. So this is a derivative of 3-pentanol with a substituent of a methyl group located off of carbon number 2. So 2-methyl-3-pentanol. So that would be the appropriate way to name this compound. What do we do in the case of where we have 2 alcohol groups? So just like with that, in naming alkenes, you want to make sure that your parent chain contains both of those highest priority functional groups. So earlier we'd included both double bonds as part of the parent chain in a diene. Now we're going to go ahead and make the longest continuous carbon chain here for this 2 alcohol group. So the shortest way that we can get both alcohol groups included is just this short 3 carbon chain. That's it. Doesn't matter that the rest of this chain of carbon extends down this way and is even longer. Doesn't matter because I need to be sure to include both alcohol groups. If I just did one alcohol group going down this other long carbon chain, that would not be an appropriate parent chain. So we're looking at a 3 carbon parent that is, let's go down here, propane. Now what's nice about a lot of these other functional groups that you're going to see with more than one of them as part of the parent chain, where earlier we saw alkenes with kind of a strange way of changing the naming, where we dropped some of the suffix along with the root. Here, actually with 2 alcohol groups known as diol, for 2 alcohols, we take the suffix "ol" and just add a di in front of it. Here, we are going to add this diol suffix in front, or sorry, after the parent name of propane. And with regards to propane, there is no change that's needed for a diol. We just say propane diol. Now you still have to number in front because, as before, the location of these two functional groups could be on different carbons. They could be on the same carbon in the case of alcohols. That's completely possible. Here I've got alcohol groups located on carbons 1 and 3. So I'm going to say 1,3 propane diol. So this is the name of our parent chain. We have one substituent, which is 1, 2, 3, 4 carbons long. 4 carbon long substituent alkyl group is butyl. So this butyl group comes off of carbon number 2. So the first part of this name is 2-butyl 1,3 propane diol. So that's how you would go about naming molecules with 2 alcohol functional groups. So they give that diol ending. All the usual rules apply after that.